Hey grade 7s, and this is the third video in a series of videos on fractions. We started this journey together and we've come this far, and things are about to get really interesting. We are going to deal with addition, subtraction, multiplication, and division of fractions. Okay, are you ready? Grab your thinking caps and let's get into fractions. Okay. So there are four rather main operations that we can do on numbers, and these operations are addition, subtraction, multiplication, and lastly division. So we'll look at first addition and subtraction, then later we'll look at multiplication and division. So when we're dealing with fractions, in order to subtract or add fractions, they must have common denominators. Remember common denominators? Do you remember common denominators? Common denominators, we just looked at common denominators in the previous video, and we said common denominators can be achieved by multiplying certain numbers to the fractions, and these will give us the same denominators in two different fractions that we might have. So let's start with something really basic. Let's start with fractions that have common denominators already. Let's say we've got 1 over 4. Ooh, what's up with my handwriting? Let's say we've got 1 over 4 being added to 2 over 4. So these two fractions have a common denominator. They both have 4 at the bottom. You see that? So 1 over 4 plus 2 over 4, this is equal to, so since they both have a common denominator, it means that we'll keep this denominator in our answer as well. So we're going to have over, so the denominator will still remain as 4 since it's common. And what we are adding are the numerators. We're going to have 1 plus 2, right? And what is 1 plus 2? 3. The denominator still remains the 4. Really simple, isn't it? Ain't it? Really, really easy to work around with. And nothing complicated there, eh? So here's one that you can try on your own. Let's say add 1 over 12 to 5 over 12. So 1 over 12 plus 5 over 12. You can pause the video and try to work that one out. Okay, so they both have the same denominator, common denominator, which is 12. So 12 at the bottom. Then we've got 1 plus 5. We add the numerators, and that gives us 6 over 12. Did you find that? Did you leave your answer as that? So when you're dealing with fractions, it's always best to simplify fractions to the lowest level to reduce the fraction to its lowest equivalent. So we've got 6 over 12. Well, 6 over 12 can be simplified now, can't it? One number can go into 6 and 12 without leaving a remainder. 2 can go into 6 and 12. 4 can go into 6 and 12. 3 can go into 6 and 12. But the biggest number that can go into 6 and 12 without leaving a remainder is 6. 6 into 6 is 1. 6 into 12 is 2. So this can be written as 1 over 2. Okay? So adding fractions with a common denominator is quite easy, quite straightforward. Just take that denominator, place it under your answer, then work around the numerators that you have. Add them and you get that, you get your answer. If your answer can be reduced, if it can be simplified, do that. Okay? Really easy. So look at more questions when we come and look at past paper questions, and we'll practice as much as we can. We'll go through as many questions as we can, so just so that we can understand and we can know how to work around fractions. Okay, grade 7s. We can move on to adding fractions which have one denominator as a multiple of the other denominator. So what do I mean? Let's say we've got two fractions, and these fractions are 2 over 3 being added to let's say 5 over 6. Okay, 2 over 3 plus 5 over 6. Do these fractions have the same denominator? I don't see it. Do you? No, they definitely have different denominators. But what we can see about these two fractions is that their denominators are related, in that one is a factor of the other. Okay? So, well, 3 can go into 6, am I right? Or how do I say it? There's a number that you can multiply by 3 to get 6. Okay, yeah, let's say that. So this is how we work around such a question. 6 can go into 3, am I right? Or is it, sorry, 3 can go into 6. 3 can go into 6 without leaving a remainder. So we can have the denominator there as 6 to be our common denominator. Okay? So follow me closely on this one. 3 can go into 6. This denominator here can go into that denominator there. So what we do is we pick this denominator and keep it as our final answer denominator, right? Then after that, got 6 there, and 3 can go into 6, right? Okay. So after that, we say, how many times does 3 go into 6? How many times does 3 go into 6? 6 divided by 3 is 2. So 2 times 2. Okay? 2 times 2. So we're going to say 3 goes into 6 how many times? 2 times. Then times the numerator there, which is 2. Right? So I love brackets. Always add your brackets. So 3 goes into 6 2 times. So 2 multiplied by the numerator that we have there, which is 2. Then what sign do we have there? We've got a plus. 6 goes into 6 how many times? 1 time. 1 times 5 is 5. Okay. Can pause the video and process everything. You can rewind and see what we've done. Okay, so let's move on. This is equal to 2 multiplied by 2 gives us a 4 plus 5. Plus 5. This is all over 9, right? 4 plus 5 is 9 over 9. 9 can go into 9 how many times? 1. Or is there a number that can go into 9 and 9? 1. So we've got 1 over 1. Yeah. And then number over 1 is simply a whole number 1. Do you see that, grade 7s? Do you see what's going on? Let's look at another example. Let's say we've got 2 over 9 plus 5 over 27. Do these numbers have the same denominator? No. This one has 9, this one has 27. So we need to look for a common denominator, right? And what is that common denominator? When you look at 27 and 9, 9 can go into 27. Should you know that? Well, now you know that. 9 can go into 27. So our common denominator there will be 27. How many times does 9 go into 27? 3 times. So we're going to have 3 times, what is our numerator on the 9? 2. Brackets plus plus, what's 27 into 27 is 1. 1 times the numerator on the 27, which is 5. 3 times 2 gives us 6 plus 5, and this is all over 27. 6 plus 5 gives us 11 over 27. Is there a number that can go into 27 and 11 without leaving a remainder? No. So that is how we work around fractions that have different denominators, but one denominator is a multiple of the other. So we'll look at questions. So if you don't understand this fully, I believe you get a clearer understanding when we come to the questions on fractions. So let's look at the third case where we have totally different denominators. Let's say we've got a fraction with 2 over 3. This is being added to fraction 1 over 5. Is any of the denominators a multiple of the other? Clearly no. So what do we do? When we have different denominators, totally different denominators, what we do is we multiply the denominators that we have. Okay? So we're going to say, let me draw a straighter line. We're going to say 3 times 5 at the bottom. When you have different denominators, we just say 3, we multiply the two denominators. Then, upon multiplying the two denominators, we're going to take this denominator and multiply it by that numerator. So we're going to say denominator 5, this one, times numerator 2. Plus, denominator there is 3, times numerator there is 1. Okay? This gives us 5 times 2 is 10, plus 3 times 1 is 3, over 3 times 5 is 15. Okay? So we've got 10 plus 3 divided by 15, which gives us 13 over 15. And that's how we work around fractions with different denominators, totally different denominators. So what if you had 2 over 7 plus 1 over 2? You can pause the video and try working this one out on your own. Otherwise, this is how we work around it. So we say 2 multiplied by 7. Then this denominator by that numerator, 2 multiplied by 2, plus this denominator by that numerator, which is 7 multiplied by 1. This is equal to 2 multiplied by 2 is 4, plus 7 multiplied by 1 is 7. This is all over 2 multiplied by 7 is 14, which gives us 11 over 14. And that is how we add different fractions with different denominators. When we come to subtraction, subtraction works literally on the same principle as addition. So when we are subtracting, all we'll be doing is changing the sign there. We'll have minus, and we'll have minus there, and we'll have minus there. Okay? Okay, grade 7s. So before we come to subtraction examples, let's look at addition of mixed fractions. So for mixed fractions, you would have, let's say, 2 1 over 3 plus 4, 1 over 5. That's a 5. Okay, let me rewrite it. How do we add these two fractions? So whenever you're dealing with mixed fractions, the first thing that you do is work with the whole numbers, then later on work with the fraction part. So what do we have as our own numbers? We've got 2 and 4. So we're going to say 2 plus 4. What is 2 plus 4? 6. So we've worked with the whole number parts. We've worked with this 2, with this 2, and that 4. So we say 2 plus 4, neglecting the fraction part. Then we come to the fraction part. The fractions are 1 over 3, and this is added to 1 over 5, right? So how do we work with this? Different denominators. So we say, find the common denominator by multiplying the 2. So 3 times 5, I'm writing 8. 3 times 5, then 5 times 1, plus 3 times 1, and then this gives us, what is 5 times 1, grade 7s? 5, plus, what is 3 times 1? 3, and this is over 15. Are we together? Okay, so what is 5 plus 3? 8. This is over 15. So that is how we work with addition of mixed fractions. So as I said, when we're dealing with subtraction, the procedures are all the same. Procedures are literally all the same. Okay? So let's look at an example on the subtraction of fractions. So literally all the same. So let's start with fractions with common denominators. So we'd have a fraction with 5 over 8, saying, let's say 5 over 8 minus 3 over 8. So just as in addition, these two fractions have the same denominator, right? So we'll say this is equal to, we'll carry the denominator that we have over 8, then we'll say we subtract the numerators, 5 minus 3. And this gives us 2 over 8. Am I right? And this can be simplified. One number can go into 2 and 8 without leaving a remainder. 2. So 2 into 2 is 1 over 2 into 8 is 4. So just as simple as addition. Nothing complicated about it. Nothing so special about subtraction. It's literally all the same as addition. So similarly, if we were to say we are subtracting mixed fractions such as 3, 5 over 9 minus 1, 3 over 9. First, we deal with the whole numbers. 3 minus 1. 3 minus 1, which gives us 3 minus 1 is 2. Then we come to the fraction part. We've got 5 over 9 minus 3 over 9. They both have a common denominator, which is 9, so that remains as our denominator. Then we've got 5 there minus 3, which gives us 2 over 9. So therefore, when we subtract this, we will have 2 over 9. Nothing complicated about it, grade 7s. This shouldn't be hard. This should be a walk in the park for us. So it's all the same, even if we had numbers with different denominators. Let's say we had numbers with different denominators. We had 6 over 7 minus 1 over 3. It's all the same, grade 7s. In this case, different denominators. So we'll say over, then we'll say this multiplied by that, denominators multiplying by themselves, 7 by 3, right? Then we'll say this denominator by that numerator, we'll say 3 times 6, I love brackets, 3 times 6 minus 1 times 7, 7 times 1. And this gives us, what is 3 times 6? 3 times 6 is 18. Minus, what is 7 times 1? 7 over 7 times 3 will give you 21. This is equal to 18 minus 7 is 11 over 21. And that's that about addition and subtraction of fractions. Addition and subtraction of fractions. So if you still feel you haven't understood, then look for the video on in which we'll do past paper questions. And once you do past paper questions, I believe you gain a better understanding on the addition, the subtraction, the comparing, and all sorts of manipulations that we can work on with fractions. Okay, so in this video we are done, and in the next video we'll look at multiplying fractions and we'll look at dividing fractions. And from there, I believe we can say we are done with fractions. So look out for the next video where we'll look at multiplication and division of fractions. Thank you very much, grade 7s. You've been a lovely audience, and I can't wait to see you in the next video. Thank you. Goodbye.